So as a preface to talking more about the design and engineering that needs to take up front, I wanted to ask Josh to tell us a little bit more about the size of the Habitat home and the cost of the home and kind of the time to build and what they experienced there.
Yeah, so in our local market, the price for labor is abnormally high, and that's driven by a number of factors, including the cost of housing. And so one of the challenges that we were seeing was the cost per square foot of finished construction. And this high cost per square foot of finished construction was driving the development of fewer larger properties. And so we put on the table that we would like to develop a structure that is no larger than 1,200 square foot at a rate below $125 per square foot. And so we're seeing in our local market, we're seeing development costs ranging from $180 all the way up to $500 a square foot for finish in some cases, more the high-end finish cases. And so we were able to deliver that lower cost per square foot through design because we're using space more efficiently, and that's largely due to the design that the Kansas State University team put forward. But also we're choosing our finishes. We're not using cheap finishes at all. We're using custom cabinetry, and we're using locally manufactured countertops. So we're using the type of high-end finish that our market is accustomed to in the home buying space, but we're delivering it with a much smaller footprint and at a much lower cost per square foot. And some of those cost savings are realized by the reduction in professional labor that's needed to assemble the project on site. And that's largely due to the use of prefabricated panels. And those panels allow us to bring large sections of walls and roof units to the site and assemble them very quickly. And we were using student groups for the assembly. So our work sites are also classrooms for architecture students and construction science students. And even with the slower pace of an educational environment and the less experience used by that students have, we were able to be weather tight in 3 days on the site, which in Kansas, the weather can be somewhat variable. So being able to identify a short section of good weather for site assembly and then getting out there and getting it done is really, really helpful, really important in the professional space as well, because it reduces the amount of mobilization necessary on the site. And so as we look forward to our current project, we've been able to further reduce that site construction time by actually extending the prefabrication to include the exterior continuous insulation and the zip panels on the exterior, so that once the panels go up, they get taped and they're completely sealed for the site and ready for siding, and they get glazed. Our current build gets glazed on site, but it could have been glazed in a shop environment, which would further reduce the time on site to build. All the builders who have come to the site, the builders and the developers who we've brought to the site, they're usually a little surprised when we tell them what our cost per square foot to assemble and our time to assemble is. And I think when they hear those numbers, they assume that we're doing that by performing at a lower quality. But when they come to site, what they see is that we are actually performing at a higher quality standard than what is typical in our building environment. We are doing it at a lower cost per square foot, and we're doing it faster. So through design, we are doing better, faster, cheaper. And that is something that developers are really scratching their heads trying to figure out how they can onboard into their delivery systems.
So Michael, tell us a bit about, the behind the scenes to make that happen.
Well, I think so I teach architecture students, and I teach them about how to practice in a future world where sustainability is of growing importance. I think prefab is a lot like sustainability because it's an integration problem, and you have to kind of start at the beginning with the idea you can't just sprinkle prefab magic on a project that you already have. So it takes a team of people that kind of knows what's going on, and no one is really sort of an expert in a bubble. Everyone kind of knows what everyone else is doing, and I think that's actually that idea translates into the field with the construction technology students and our collaborators too. So this is a daylight analysis for our houses. We use a lot of technology you would normally just use in a commercial building, but no one ever thinks to use it in a house. As an aggregate, our homes in the US actually use more energy than commercial buildings. So when you drive around, you see all those office parks lit up at nighttime with lights on in empty offices. Like actually houses are using more energy, which is insane to me. Also, the average American household emits about twice as much carbon dioxide emissions from their utility consumption than they do from driving. So everyone's really self-conscious about their cars, but our homes are really the problem. So designing for daylight, we have the tools to do that. So we do that in a very simple way. The windows in our houses are usually around $300 to $3,500 for the window and door package. Very inexpensive when you design to performance target and really understand what you're doing and use the right tools. So we use passive first principles to reduce load, good shading of the house, using some of that winter sun is beneficial, allowing for natural ventilation. Most climates in the U.S. have enough available good climate and air movement. It doesn't take a lot of windows to do that. So our houses are not huge glass boxes. And daylight can reduce a lot of your electricity load by keeping the lights off in the daytime, but it can also help with cooling. So a lot of heat gain in a house comes from lights and also equipment. And if you bring that down, you're allowing that house to cool better. And we also use a fully insulated slab that helps as kind of a thermal flywheel effect. So it kind of tempers the fluctuations in temperature in the climate. When you put all that stuff together, you get a house that works really well, but it's also a healthier house. There's a lot of evidence we see in school and commercial buildings that daylight, connection to the outside, all those really good design principles, they help people. They enhance health. And I think Ted had mentioned that there's a lot of important stuff in the details. So part of our prefab system is that we can use things like exterior insulation. We can reduce a lot of thermal bridging. I joke that in practice, if you sit down with a contractor for the first time and you say continuous insulation, it's like a cartoon. You just see like a puff of smoke and then they're gone. So we can use continuous insulation. It's really not a big deal. We keep our roof designs very simple as well. That helps make a good solid roof. But we've worked that out, and it's actually there's a lot of flexibility in these systems too. I think that's also a misunderstanding with prefab, that if you prefab a building, it has to be a box or it has to be a certain shape. I think it's more efficient to have a certain shape, but that can also be flexed. But I see what we do as not just the having a value in sort of the shop and the production side of things, but also all of this stuff has to come from somewhere, and the design and the planning part is really important. We actually make these drawings, and a lot of times the drawing set, by the time you get to the end of the project, it's really clean. It's not all like ratted, like bent up and torn up and doesn't have drawings all over it, because like it only goes together one way, and people can see it going together. So that's a kind of another funny little anecdote.
Mm-hmm. Ted, anything you'd add to that?
Yeah, I love the idea of keeping projects simple. It makes it easier for everybody to build. And if you've built a number of houses, every single house has a couple of like really tricky, weird spots, and just iterating over years and figuring out how do we eliminate those tricky, weird spots and have designs that are super buildable, and then repeat those, repeat some of those designs. So
Well, it's a value proposition too. So I think there's like the HGTV effect where what consumers want is they want a really complicated house from the curb, and then they want it to be kind of the same inside. And I think the value proposition of designing the thing better is that the inside of the house is more functional. It's more focused on how people actually use the house. And simple can actually be more desirable if you do things that people really want, which they want space and they want functionality.
daylighting, I mean,
Yeah.
it's huge. Like having a well daylit house. I mean, we try to put the same paint color on the inside of every house for that reason. Just a bright white, neutral paint color, because then the light bounces around. It doesn't get stuck there. And so you can with combination of where you put your windows, what the visible light transmittance is on all your windows, and those are numbers a lot of window manufacturers will let you play with. You say, I want a 0.5 visible light transmittance, and you'll find the glass layup that works for that, and usually it doesn't cost anything extra. Kind of with the cardinal glass and stuff that we're using, we can specify all that, the solar heat gain and the visible light transmittance.